few students have asked me to go over drawing atoms and understanding protons, neutrons, and electrons, especially in your last assessment. And I wanted to make sure that you guys are prepared if you want to retake the atoms and molecules assessment. So I'm going to go ahead and do this video for you guys, especially addressing that question of what is wrong with this model, and your short answer response for how to fix the model. So looking at the periodic table here, I'm going to go ahead and do a couple examples. The two examples on your test, it was lithium. I'm going to go ahead and do beryllium, and I'm going to do boron for you, following a specific pattern. I'm going to want you to do then fluorine afterwards. So right here, if we zoom in, I'm going to go ahead and do beryllium, and then I'll do boron. So beryllium is number 4 on the periodic table, if you look at the 4 up top. And the symbol is Be. The element name is beryllium, and the atomic weight is 9.012. So I'm going to go ahead and draw that a little bit larger so that we can all see what's going on. So I'm going to start by drawing a square. Writing the number 4, I'm going to go ahead and put Be. Now since I'm using a Sharpie, I'm not going to write out the element name, but the atomic weight is 9.012. Now, we know in each atom there are going to be protons, neutrons, and electrons. Remembering that protons are positive, electrons are negative, and neutrons are neutral. They balance out to no charge. So in here, the number up top right here is the most important number on the periodic table. Okay, that is called the atomic number. And the atomic number is always equal to the number of protons. So there are 4 protons in beryllium, in each beryllium atom. Now, in 8th grade science, we're not going to go anything beyond saying that electrons are equal to the number of protons. Later on in high school and college, you will find out that electrons, they change. That number can change. But in 8th grade, we're always going to say that protons and electrons are equal. So notice that for each positive charge, there's a negative charge, so we end up with a neutral atom. We don't have an atom that has more positive charges than negative charges. Now for neutrons, this is where it gets a little bit harder. So this 9.012 is the atomic mass. Now, each proton has an atomic weight of 1, each neutron has an atomic weight of 1, and electrons are pretty much 0. They're actually 1/2000th. So that's not a 6, that's a 0. Okay. Now, since electrons are practically 0, we ignore them for atomic weight. For the atomic weight, or mass, I'll write weight there too. This is going to be equal, once you round it, so this would round to 9, equals protons plus neutrons. We know that there are 4 protons, so 9 equals 4 plus the number of neutrons. We could rephrase this by just saying what is the difference between 9 and 4, so 9 minus 4 equals 5. But let's go ahead and do the math to check that. If we have 5 neutrons and 4 protons, when we add those together, do they equal 9? Yes. So there are 5 neutrons. Now, I'm going to go ahead and draw this. I am going to go ahead and use a circle with a plus in it for protons, a filled-in circle for neutrons, and a dot for electrons. As I draw this, I'm going to go ahead and draw 4 protons. And 5 neutrons. Notice how it's very obvious and very clear that there are 1, 2, 3, 4, 5 neutrons and 1, 2, 3, 4. Whenever you draw a picture, make sure it's very clear. Now, in real life, because of limitations, we can't draw the electron cloud being huge. But in reality, electrons are very, very, very far away. If this was on the piece of paper we're sitting in a classroom, the electrons would be on the outside of the school in the field by the road. They're so far away. So we're going to go ahead and just draw this circle. The circle doesn't actually exist, but we call it the electron orbital or shell, just to show that the electrons go around the nucleus. This line isn't real. This is the nucleus in here. This shell has nothing to do with the nucleus. Okay, this is the outside shell is just a line to show that the electrons are going around it. There are 1, 2, 3, 4 electrons. It does not matter where you put them on all around the circle. In real life, they're actually farther apart electrons from the nucleus and closer ones. But in 8th grade science, we're just going to say they're going around it, kind of like an orbit, like planets go around the sun. So we have 1, 2, 3, 4 electrons, 1, 2, 3, 4 protons, and 1, 2, 3, 4, 5 neutrons. This is an atom that is correctly drawn, but in reality, the electrons should be farther away. Now, if you see protons anywhere else besides the nucleus or neutrons, then they need to be in the middle. There could be the correct number of protons, but if I put one of the protons out here, there would be the correct number, but it wouldn't be in the right place. I'm going to go ahead and end this video, and I'll do another one of boron. If you feel like you need another one, you're welcome to, and I'm also going to give the answers for fluorine in a separate video. So if you feel like you're ready, you can go ahead and try fluorine and just check the answer video for fluorine. If you feel like you need one more practice, you can tune into the next video.